We are going through exercise 16D. This is question 1, which says the following. Let's give it a read. It says, by considering the secant through the points where x equals 1.2 and x equals 1.3, estimate the instantaneous rate of change of y with respect to x at the point on the curve y equals x cubed plus x squared, where x equals 1.3. So that's a very, very wordy question. And before we delve into this, I really want to take a step back and make sure you understand what's happening graphically here. So let me really stress this point, that when you're answering a question like this, you shouldn't graph it. You could immediately dive in and do all you need to do algebraically. But because this is question 1, I want to make sure you understand what you're doing visually, graphically, before we get into the nitty-gritty. So what I've drawn here is simply y equals x cubed plus x squared, and I'm actually going to refer to this as f of x. You're going to see why I'm going to do that later. Now, what this question is asking us to do is to estimate the instantaneous rate of change. The instantaneous rate of change where x equals 1.3. Now, what that means is, if I was to come here for a second, I'm going to come to 1.3. Let's say that's here. 1.3. Actually, let me say it's here. 1.3. And if that's 1.3 here, then over here, this is going to be f of 1.3. And what I want to find is the instantaneous rate of change. Now, we can visualize that by putting in a tangent at that point. So my tangent will look like this. It's only going to touch it at that 1.3, and the gradient of that tangent is going to be my instantaneous rate of change. Now, we actually can't figure out the gradient of that because we don't have 2 points. So what we're going to do is we're going to estimate, we're going to approximate our instantaneous rate of change by finding the gradient of my secant. So that's now where we come to our secant. So I'm now going to put in x equals 1.2. Let me come over here. Let me say that this is that 1.2, which means over here, this is going to be f of 1.2. And what I'm going to do now is draw a secant through these points. Let me grab this, whoops. Come over here, grab this, and I'm going to draw a line through my 2 points, just like that. Now, hopefully you can see that my secant, the blue line, and my tangent, the green line, they look pretty similar, don't they? They look like their gradients are about the same. And what you have seen in class is that as we bring our 2 dots together, our 2 points, as these come closer and closer together, the gradient of these 2 lines come closer and closer together as well. So because I can't find my instantaneous rate of change, my green line, because I only have 1 point, I can approximate it by finding the gradient of my blue line, the secant. So how are we going to do that? Well, we're going to do it by finding our rise over the run. My rise is simply going to be this distance right here, from here to here. So f of 1.3 to f of 1.2. So I'm going to subtract those from each other, 1.3 minus f of 1.2. Then I need to find my run, which is simply going to be the distance between these 2 points. So it's going to be 1.3 minus 1.2. Hopefully you can see what we're doing here is y2 minus y1 over x2 minus x1. Very simple mathematical stuff here. Having done that now, I simply just need to solve it. Now I'm going to cheat and I'm going to use my CAS. So let me bring out my CAS. Let me come over here for a second, and it's going to be a few things I need to do. The first of which is I'm going to have to define f of x. Whoops. I'm going to define f of x as x cubed plus x squared. Now that that's defined, I can put in this. So it's going to be control this f of 1.3 minus f of 1.2 over 1.3 minus 1.2. Enter. And there you go, 7.19. So let me come over here now. And let me write that in, 7.19. 7.19. So what is 7.19? I mean, we've done all this work and we've figured out that we have this number. What does this number represent? Well, what it represents is an estimation, an approximation of the instantaneous rate of change of y with respect to x at the point on the curve y equals x cubed plus x squared, where x equals 1.3. So it approximates that tangent that we started with, and we did it by getting the gradient of the secant. Hopefully that makes sense to you. It's one of those things that it really sounds complicated at first, but the more and more you do it and the more you graphically understand it, the easier and easier it becomes. So hopefully you've persevered with this video and you've gotten through it all and you have some sort of understanding now, and good luck with the rest of your questions.